All right, this section continues from the first video that we made, which was about solving absolute values, equations, and inequalities. So the special case is you're always going to get no solution or all real numbers. So for number 9, you isolate the absolute value bar. So you subtract 16, gives you -4, divide both sides by 2. So you have the absolute value of x minus 3 equals -2. Remember, you can pause this video at any time to take notes. All right, so absolute value equal to a negative. Absolute value is always going to be a positive. When will a positive equal a negative? Never. So this one is no solution. Now, you can have negative answers. For example, on the front of our notes, when we were solving some equations, we got x equals 4 and x equals -10. And when we plugged them back in, they both worked. So they were both correct. So you can have x equals a negative, but the absolute value bars cannot equal a negative. All right, number 10, you want to isolate the absolute value bar. So you subtract 10, gives you -6. Divide both sides by 2, so you get the absolute value of x plus 7 is greater than -3. All right, absolute value is always going to give you a positive. When is a positive greater than a negative? Always. So that's all real numbers. If you want to do that on a number line, you would shade the whole thing. All right, number 11, isolate your absolute value bar. So you subtract 16, gives you -4. Divide both sides by 4, so the absolute value of x plus 3 is less than a negative. So once you have the bars by themselves, you want to check. If you get a negative here, you want to think about what the situation is. So this is a positive. Absolute value will always give you a positive. When is a positive less than a negative? Never. A positive number is never less than a negative, so that's no solution. So for that number line, you would just leave it blank. Number 12, isolate your absolute value bar. So you would subtract 12 first, gives you -8. Divide both sides by 2, so you have the absolute value of x plus 5 is greater than -4. So absolute value always gives you a positive. When is a positive greater than a negative? Always. So that's all real numbers. All right, our last bit is 2 word problems. So on the front of your notes, we did not write down what to do for word problems. So when you're writing absolute values, it's the absolute value of x minus the starting value less than or equal to the change. All right, so let's do an example so that'll make a little bit more sense. The average temperature in Lansing, Michigan during January is 28 degrees plus or minus 10 degrees. Write and solve an absolute value inequality to represent the range in temperatures in Lansing. So x minus your starting value less than or equal to your change. Well, what temperature did it start at? It started at 28 degrees. That was your average. And what is the change in the temperature? Plus or minus 10. So you just put 10. Okay. This is really what I am looking for, you being able to write the equation. But let's solve it just so I can show you more about what happens. So this is a less than. So you would squeeze it in. You would do a +10 and a -10. And then to solve that, you would add 28 to both sides. So that gives you +18 and +38. And remember, it was temperature. So the temperature in Lansing is between 18 degrees and 38 degrees, which makes exactly sense, right? The average is 28 plus or minus 10. So that would be down 10 would be 18, up 10 would be 38. Okay. Last one, the average rainfall in Smithfield during the spring is 5 inches plus or minus 2 inches. Write and solve an absolute value inequality to represent the range in temperatures. So x minus your starting value, starting at 5 inches, and the change is 2 inches. So if you were going to solve that, it's less than. So you would put the x minus 5 in between +2 and -2. And to solve that, you would add 5 to both sides. So that gives you 3 and 7. So the rainfall is between 3 inches and 7 inches, which makes sense based on the word problem. So this is what you need to be able to make sure you know to represent this problem in that way. All right, you can go back and look at any part of this video that you want again.